Difference between Scala and Java, for instance, and C as well, is that the class declarations can be made much smaller in Scala. Of course, in C there is no class, but there is a similar concept of a struct. So this single line is the class declaration, and these are the parameters to the constructor, and they become attributes of the class automatically. Another difference is that you can redefine operators as in C++. So we can write this function. The function is like this, just introducing it with def, the name, parameters, and return type, and here comes the definition. So this is big int, which is it will eventually become, I mean, it is in the implementation it is Java's big integer. So we can write it like this, having redefined operators to compute the factorial. And it's quite obvious that this single line is much nicer than this thing here. Furthermore, Scala is statically typed, and that is in comparison to Lisp, Smalltalk, Ruby, and Python and other languages, which are dynamically typed. So what is why is that a good thing? Well, you get the type checking at compile time, which is well, it's a matter of preference, but clearly it has some advantages to get an error message as early as possible. So the compiler must check that the types are correct. It's the same thing for C. There the compiler must check it as well, although there are cases in C where it cannot, if you use this standard argument. But we will come to that later. We will see what we will do now is to look at the small program and see when a compiler is forced to check, I mean to complain about the types. So if we have this program, and here is a quiz, which language is it? So we define the function sumList, which will add, I mean it will sum the values stored in the list. So we can create a list containing these numbers and print sumList like this. Okay, and we can do this as well with the string. That's not a good idea to add the strings, but well, the compiler doesn't complain until we run the program. Okay, so which language is this? It's Common Lisp. And when we run it, this was several years ago, but we get a very fast reply if we use CLisp. And it complains that this Z is not a number. And why Z and not X? Well, it is because we are extracting, I mean we are getting the numbers to add starting at the end of the list. So it's Z. Okay. If we do the same in C, and you don't have to read this, but oops. Well, it's actually good to see this. We defined a struct which is similar to a class, and we have a next pointer and a value. And here we do the cons, which means adding a value as a new list item to the front of the list. Okay, so this is the list and this is the value, and we create a new link, and if we didn't get in a memory, we complain. Otherwise, we set the value and the next pointer to the rest of the list and return this new one. Okay, so oops. So we can create the same list in C as we did in Lisp, like that. Okay, and then when we run it, well, not run it, but compile it, the compiler will complain that there is an that one should go away. Oh, it doesn't, never mind. That there is a static type error. So GCC complains about this, that you cannot add an integer and a pointer to a character. Clang, the Google and Apple compiler, not only them, but mostly they who develop it, it also complains. Okay, and Scala, it will say like this. If we compile this, well, it found list of strings, and it was required to have a list of integers. So it will not run the program. And by the way, here is how we can do this in Scala. It's similar to the common Lisp function. And we first check if the list is empty, then we get the value 0. Otherwise, we get the value stored in that list node as head, and then we add the rest of this using tail to get the rest of the list. One more thing to note is that the compilation time is quite severe, and this was done. This measurement was done 2019. A few years ago, it took 11 seconds to compile this. So be prepared for longer compilation times than you are used to. If we compare the common Lisp compiler, it could both compile and run the program extremely quickly. Okay, but that is okay, never mind. That's outside of the scope of this lecture. To improve the compilation time, there is a compiler server so that some initialization can be avoided, and it's called FSC instead of Scala C. Okay, and for the lab, I think it will be easier for you if you don't use any of this. Well, underneath it is used, but there is something called the Scala build tool, and with it you type like this: Scala build tool, run, and input to the program. And what happens then is that this Scala build tool checks that you have the required libraries. If you don't, it downloads them, the proper version, and then starts the compiler and then runs the program. Okay, so this is the input for this input comes from lab 6 of the algorithms course, and you will want to see this number when you run the labs. Okay, and for all the labs it's sufficient to just type make, because the labs will always have a so-called make file, so you just type make and it will run what is needed. And this took 10 seconds to compile the program, which is quite horrible. It's only 474 lines. Of course, it has to check various things, but it's still outrageous in my view.